chemical reactions. And so the first thing that we need to discuss if we're going to talk about chemical reactions is how to write them and how to balance them. And that's our topic for today. Before we talk about balancing them, we need to talk about writing out chemical formulas in a little bit more detail than we already did. So you guys know the basic rules for writing out the letters. CO2 is carbon dioxide. We're just going to add a little bit of information to that. When you write a chemical formula, it should always tell me three things. The first two you kind of already know about. Thing number one says the kind of atoms using accepted symbols. For example, the symbol for hydrogen is an H. The symbol for molybdenum is MO. That kind of thing. Now those symbols we've already used. In the last section we talked about naming ionic and molecular compounds. So I'm talking about the letters when I say the symbols. The second thing the chemical formula should communicate is the simplest ratio of atoms. And that's where the subscripts come in. For example, the formula for water is H2O, indicating I have 2 hydrogens, 1 oxygen. The third thing is the thing that's really new, because we haven't focused on this until now. The third thing is the physical state of the substances at STP. I'll remind you what STP means. We talked about it when I referred to the properties of ionic and molecular compounds. STP is standard temperature and pressure. So we're saying under normal conditions, this would be the state of this substance. Now there are 4 little abbreviations here. They each mean something. The S stands for solid. The L for liquid. The G for gas. And AQ for aqueous. Now we used AQ and S a little bit when we talked about solubility, but our goal now will be for every chemical formula we write to also indicate the state. Now that is the information. We're going to do some examples on the bottom so I can show you some common mistakes that people make. But before I do that, would anybody like to ask questions about the 3 things that a formula should communicate? So you'll see that I have on the left correct, on the right incorrect, and then I have 3 examples down the middle. And this is because I want to illustrate to you common things that I see people do incorrectly when they're writing out a chemical formula. The first example I'd like to use is oxygen. The most common thing that I would see happen when I say, what's the formula for oxygen, is that someone would just write the letter O. Oh, that's oxygen. What more do I need to say? But that's not the correct chemical formula for oxygen. Now, I'm sure that somebody knows what the chemical formula is. Does anyone want to tell me what I should really write for oxygen rather than just an O? Yes. It is O2. So here's the first thing. Oxygen has a 2 when you write it. Now, how did Isaac know that? Does anybody know how he knew that? I'm sure it's because he's smart, but also there's a trick that I taught you about that would help you know that there should be a 2 there. Funny little sentence about having not as intelligent friends as perhaps Isaac is. That's it. I have no bright or clever friends. Stupid people was the fun little sentence I told you guys to use to remember all of the elements that have a subscript in their formula. I, if you remember, stands for iodine, H for hydrogen, nitrogen, bromine, oxygen, chlorine, fluorine, sulfur, and phosphorus. Now the first bunch all have a 2. Sulfur and phosphorus are at the end because they have different numbers. Sulfur has an 8, phosphorus has a 4. Now, if I say in words, what's the formula for oxygen, you need to use this little list to remind yourself there should be a 2. Now, there's still one more thing missing from oxygen's formula. Take a look at the 3 points at the top. One of them isn't there. I am missing the state. Now, does anybody know what state oxygen is? Who said yes? Yes. What is it? A gas. So oxygen is a gas. Now, sometimes you might know that because you have previous knowledge of the substance. But let's say you had never heard of oxygen before and you didn't know what it was. How would you know that oxygen is a gas? Please take a moment and take out your periodic table and I will show you. That I knew that because of the periodic table. And anytime I have an element, not a compound, it doesn't work for compounds, it only works for elements. Anytime I have an element, the periodic table will tell me the state. Would anybody like to ask any questions about this first example about oxygen? Michaela, Gianna, you guys have questions? No? Okay. Now the second example and the third really illustrates something about compounds. In the second example, I have a calcium chloride solution. Here is the common mistake I'll see people make. They'll write the formula for calcium chloride, which is CaCl2, and they will write as the state L for liquid. And that is not quite correct. Now the formula is right, and I'll just maybe back up a step and remind you that I swapped and dropped. So to get that formula, I wrote down the charges for calcium and for chlorine. I swapped them and I dropped them. So the 2 from calcium ended up next to chlorine. The 1 from chlorine ended up next to calcium, but I don't have to write it when it's a 1. Now that part comes from our last section. The part that's new is the state. Anytime something is a solution, what does that mean? It means there was a solvent. It means in virtually every case that we would discuss in the scope of Science 10 that I put something in water. And we know what happens when something is soluble in water. We should, instead of writing an L, write one of the other choices. Does anybody want to tell me what the other choice should be? You say AQ should be the symbol. So remember, we talked about your solubility table. When something is soluble in water and I get a solution, AQ is the state that I should write. Now the last one is my way to try to illustrate to you that there are lots of ways to indicate the state. Calcium carbonate powder. The formula is CaCO3, and sometimes when I don't specifically write the word that references the state, people are unsure. A word like powder tells me that the state should be solid. And so sometimes when I'm trying to indicate solid, I won't say the word solid, but I'll talk about something that is a solid. I might say a piece, or a chunk, or a crystal. Or I might even reference an object that's solid. And so sometimes knowing that something is solid, you have to read a little bit more into the question. Now the other thing I'd like to point out is that this is an ionic compound. Ionic compounds are solid. Unless we say something about them being dissolved in water, they are all solids. That was one of their properties. So if I had not said anything, if I just said calcium carbonate, you should still be able to tell me that that's a solid because it's an ionic compound. Now those are some common things that I see people make mistakes with, but we'll do some more examples to further illustrate how you would write out a chemical formula. Up until there, does anybody have any questions that they'd like to ask? Does anybody still need this screen to be up because they're writing something down? Fantastic. So now we're going to move from just a formula to writing out a chemical equation. So this is where we write out all of the things that are part of the reaction and what do I get from them. And there's a little bit of vocabulary that goes along with chemical equations. The first bit of vocabulary is the idea of conservation of mass. Chemical equations all illustrate the conservation of mass. What that means is that if I take the mass of reactants and the mass of products, they should total up to the same amount. What I'm trying to say here is that I need to have the same amount. I can't have magically destroyed some of my substance during the reaction, nor can I magically have made some more. I have to have the same amount of substance on both sides of my chemical equation. Now, as a point of vocabulary, what is a reactant? A reactant is what's on the left side. It's what you start with. A product is what's on the right side. It's what you end up with. So those two vocabulary words are ones that you will see anytime we're talking about chemical equations. Now, when I write out a chemical equation, I'm going to separate the reactants on the left side and the products on the right side by an arrow. So I'm going to make an arrow that looks like that. I am not, absolutely not, going to make an equal sign. I am never going to say that what I started out with and what I ended up with are the same. I'm using an arrow to indicate transformation. These substances became these other substances. Sometimes you might see an arrow that looks like this. It's a little bit beyond the scope of our course because it's talking about reactions that are reversible. But if you happen to see that, it's not going to change anything in our discussion. I'm just showing you that that's another way that we could write an arrow. Now, when I want to write out the whole entire equation, I'm going to start with the formulas. Then I'm going to add states of matter. And then I'm going to do something called balancing the equation. And we're going to spend a little bit of time talking about that very specifically. So when I'm writing out a chemical equation, this is the theory and the background and the instructions for it. Am I going to ask you what goes on the left, reactants or products? No. I'm going to ask you actual examples, and you're going to show me that you know that reactants go on the left by writing them on the left side. Am I going to ask you whether I should put an arrow or an equal sign? No. You're going to show me that you know that by using an arrow whenever you write a chemical equation. So I'd like to do this first example. Most of what we'll do in this section is take written words and convert them into chemical formulas. So in this example, I'm going to show you how to look at a sentence and deduce where things belong. I'm going to highlight the word combined and the word produced. When you read a sentence, the first thing you should do is pick out words that indicate which things are the reactants and which things are the products. The word combined, or maybe mixed, or reacted, are all ways of indicating the reactants, the substances that I start with. The word produced, or maybe made, or even if I want to be fancy, synthesized, are all ways of indicating what the products are. Now, a lot of the time, the sentence will be written in an order that goes along with the reaction. So you can see here, I wrote the reactants first and the products second, but that won't always be the case. So you need to look for those key words so you can identify which substances I started with and which ones I finished with. Now in this case, I can see that I had hydrogen and oxygen combined. So I'm going to start with that. The formula for hydrogen is H2. I know it's a 2 because hydrogen is on that list. I have no bright or clever friends. Hydrogen is a gas. I know that because of my periodic table. If there's more than one substance on one side of the equation, you put a plus. I know I have hydrogen and oxygen. Oxygen, we already saw, is O2 gas. Now, I want to show, in turn, what my products are. We indicated that we're going to use an arrow, so that's my next step, an arrow. And I'm going to write down the formula for water. Now, H2O is a liquid. It's said that right in the sentence, but that's one that I would expect you to know. You should know that water is a liquid. I have the habit of writing a cursive L there. I don't know why I do that. It must be how I learned it in the first place. You don't have to. You can just write a lowercase l. But I find that sometimes people mix up lowercase l's and capital I's. Even though there's no I here, I like to make sure that it's very clear. Now this is the basic thing that you need to be able to do. Write out all the formulas on the correct side of the equation. The last thing that you need to do is what we call balancing. So I'd like to refer back to the very first point, conservation of mass. I said that I have to have the same amount on the left and on the right side. So if you look at this reaction, do I have the same amount? Do I have the same amount of hydrogen and oxygen on both sides of the reaction? How about raise your hand if you say, yeah, you're good, nothing needs to change. Or raise your hand if you say, no, there's something missing, you have to fix it. Yeah, this is where I would raise my hand too. If you count, you'll see that I don't have the same amount of oxygen on both sides of the reaction. So I'm going to show you what I do to fix that, and then we're going to go through the steps on how to assign numbers for this. I'm going to add a big number 2 right here. This number 2 is called a coefficient. Doing that is like I'm multiplying. So this number 2 applies to hydrogen and to oxygen. So I'm saying I want there to be 2 waters, not just 1. Now when I do that, I fix my oxygen problem, but I make a new problem. Now I have 2 oxygens on both sides, but I actually have 2 times 2, 4 hydrogens. So I fix that by adding another coefficient. Now if I count, I have 4 hydrogens and 2 oxygens on each side. Mass has been conserved. I have to have the same number of atoms on both sides of the reaction. Would anybody like to ask any questions about this little example here? So when we're talking about balancing, I'd like to give you some instructions. They're not really rules. They're just suggestions for how to approach the concept of balancing. The first thing that I will suggest is that you always begin with the atom that has the biggest number. So when you look at all of the substances in your reaction, find the highest number and start with that substance. It could very well be that lots of things have the same number. In that case, there's no real rule for what you start with. But if one atom has obviously a bigger number than others, that'll be the one that you begin with. And so when I talk about number, I'm talking about the subscripts. The next step is a little bit of math. If I recall, this is something that you do in like grade 8 math. Lowest common multiple. So once I find the atom that has the biggest number, I look on the reactant and the product side, and I ask myself, what's the lowest common multiple to make those two numbers even? Now the third step, and I'm just going to scratch out this beginning part because it's actually not always true, and I think it will confuse people more than it will help them. I'm just going to say, write a coefficient for both of the elements or compounds that we're dealing with. So you'll start with the atom that has the biggest number. You'll determine the lowest common multiple between the reactant and product, and then you'll write a coefficient for both of these elements or compounds. And then you'll continue on. You'll balance the remaining atoms using the same strategy, remembering that your overall goal is this. The number of atoms of each element must be the same on both sides of the equation. So I'll just pause here. All right, so I'm going to do this example here to help illustrate to you how you should go about balancing an equation. Now in this first example, I give you a sentence, and I'd like for you to write the balanced reaction that goes with it. So we'll go through the same steps that we did before. In this sentence, I see the word react, and I see the word produce, and I know those are my key words for figuring out the reactants and the products. So in the question it says, I have an iron nail that reacts with oxygen in the air, and it produces rust, otherwise known as iron 3 oxide. So I've identified my substances. My next step is to write them out on the correct side. Since the two things that are reacting are iron, which I would write as Fe solid. Iron's symbol is Fe. It's not on the list. I have no bright or clever friends, so I don't put a number. And I know that it's a solid, A, because it said it came from a nail, which is a solid object. But B, iron is an element. I look on the periodic table. It's yellow, so I know that means it's a solid. It reacts with the oxygen in the air, which we already knew was O2 gas. And what do I produce? Iron 3 oxide. So just so we're clear, iron would have a charge of 3 positive. Oxygen has a charge of 2 negative. I would swap and drop to come up with Fe2O3. And I would say it's solid because it is an ionic compound. And ionic compounds are solid unless we say we've dissolved them in water. Now the next thing you need to do is look at your substances and find the one that has the biggest subscript, the biggest number. In this example, that's oxygen. There are 3 of them here and 2 of them there. So I've identified that. My next step is to come up with the lowest common multiple. So the lowest common multiple of 2 and 3 is the smallest number that I can divide them both by, or that can be divided by both of them. That means the answer is 6. So my lowest common multiple is 6 for oxygen. On the right side for oxygen, I have 3. On the left side, I have 2. How am I going to get 6? Well, over here, I would multiply by 3. That means I put a coefficient 3 in front of the substance that oxygen is a part of. On the right-hand side, I had 3. So if I multiply that by 2, I will get 6. That means I put a number in front of the compound that oxygen is in. I would never split up a compound You can only put a coefficient at the beginning. You can't put it in the middle of a compound. Next, I would take a look at iron. On this side, I have 4. I have 4 because there's a 2, and then I added that coefficient 2. 2 times 2 equals 4. On the left side, since there's no number, it means I only have 1. So what's the lowest common multiple for iron? 4. The lowest common multiple of 1 and 4 is 4. Since I already have 4 on the right, I just need to fix something on the left. I had 1. I want 4, so I multiply by 4. 4 becomes the coefficient that I add. And so you'll notice that I suggest that you keep a tally, that you count how many atoms there are, and that you always continuously check at the end of the question, have I changed anything? So even though I did them one at a time, it could be that I add a coefficient that changes my answer. And so you just need to do one last check at the end. I have 4 and 4, I have 6 and 6. Okay, I'm good. As long as you have the same number of atoms, your equation is balanced. Now the last thing that I'll mention, and we'll see some examples of this, is that it's possible that you could reduce your answer. Sometimes you might find that you have all even numbers. So for example, I could balance this equation by writing 8, 6, and 4. It would be balanced. I would have the same number on both sides, but I would not have the simplest ratio possible. So just like when we're writing an ionic compounds formula, if I can reduce, I want to. So I'm going to pause here,